You get some problems where you need to use more than one rule, or probably more likely the sine rule and then SOHCAHTOA. Or if you don't remember SOHCAHTOA, don't worry about it. There's no point learning something new just for one question. We can just do the sine rule twice. Okay, so if we have a look at the first one here, we've got the position of two surveyors who are looking to the top of the flagpole at T. From position A, we've got an angle of 33 degrees. From position B, we've got an angle of 25 degrees. The distance AB is 80 metres, and the height of this surveyor is 1.6 metres. So I want to find the height of the flagpole. Okay, so I want to find the height of this line here. Okay, so I know, oh, I've made a right mess of that. I know the wee bit at the bottom. So I want to find this height here. Oh, I've made that even worse. I know this wee bit at the bottom is 1.6, so I know from there to there, oh dear, is 1.6. So I need to find this distance here. So that's my aim. Okay, if I look at this as one big triangle, then I know one side and I know two angles. If I look at it as two right-angled triangles here, I've got right angle here and right angle here, then here I've got two angles, or essentially all three angles, but I don't have any sides. Same over here. I've got my angles, but I don't have any sides. So there's nothing I can work out there. So we need to treat this as a big triangle to begin with, because I know the length of this side here. I'm going to take this as my big triangle. So there's my 80. That's A, so that's 33 degrees. That's B, so that's 25 degrees. And what I'm going to find is I'm going to find either this side or this side. It doesn't matter which one I find, because that then gives me the length of the side in one of my smaller triangles, which means that I can then work out my height. Okay, so I'm going to find, let's just get rid of one of them. I'm going to find this one here. Not for any reason at all. I just picked one. It makes absolutely no difference. Okay, so I have two sides. No, I've got two angles, one side. So I must be using the sine rule. It's A over sine A is equal to B over sine B. And it's always going to be the sine rule if it's one of these more complicated ones. I should really change that title. I keep saying this. I keep forgetting to do it. And get rid of the cosine rule. If you have enough information to do the cosine rule, you also have enough information to go straight to just finding the length of the side you want. Okay, I want to find this one here. I'm going to call it x. So x over sine 33 is equal to 80 over sine 80 matches up with this angle here. Don't have this angle at the moment. Angles in a triangle add up to 180, so I can work out what that angle is. Take away the other two from 180. Oh, that didn't work very well. It was 122 degrees. Sine 122 degrees. Here I'm dividing by sine 33, so I can take that to the other side and times. So I get 80 sine 33 over sine 122, not 112, that's going to right. So that line there is 51.4 metres. Be very careful with what you have found out. I have found out the length of this line here. That's now 51.4 centimetres. I'm now going to take this triangle here. Okay, so starting at T, down to the bottom of the line, out to B and up. Now if you can remember SOHCAHTOA, you can do SOHCAHTOA for this. So that's 25 degrees. I've got this side out to be 51.4. I don't know that one, that's the one I'm trying to find, and I don't know this one, it doesn't cut it in half. If it cut it in half, it'd be an isosceles triangle, which is not. Okay, I'm going to use the sine rule again. So A over sine A is equal to B over sine B. Remember, right angle, 90 degrees. So these two match up, these two match up. Perfect. So I get x over sine 25 is 51.4 over sine 90. Now, sine 90 is just 1. So essentially it disappears. We can keep it in. If you used SOHCAHTOA, if you just ignore the sine 90, this is what you would end up with, 51.4 times sine 25. Type that into a calculator. I can find my calculator, there we go. 51.4 divided by sine 90, just to show you this part equals, it's just going to equal 51.4 times sine 25. You can type that all into your calculator in one go. I just wanted to show you that sine 90 just becomes 1, so it's not important there. Which is 21.7, not centimetres, metres. Our total height then, we need to add on our surveyor. It was 1.6 metres tall, so add them together. Which is 23.3 metres. Okay, let's try another one. Question 2, we want to calculate the height of the cliff. So we want to calculate the length of this line here. Okay, so let's see what we've got. We've got this triangle here, so that's 12 degrees, that's 35 metres. We've got that's 18 degrees. We don't have any of the sizes at all on this triangle here with the one that we're trying to find, so it's no use to us. So let's go back to this triangle here. So there's my AB at 35 metres. That goes up to D. That's 12 degrees. We've also got this angle here. Here is a straight line. So if that's 18, straight line angles in a straight line need to add up to 180, so that must be 162, no, 162 degrees. That's not very clear, it's just 162 degrees. So I've got one side, I've got two angles, so I can use the sine rule. So A over sine A is equal to B over sine B. We are aiming to find a side inside this little triangle here. So I want to work out the length of BD. So that's the one that I want to find, because that would give me a line inside my small triangle. So I'm going to make that x over, cross on that angle is, cross on that side is 12 degrees. So we get x over sine 12 degrees is equal to 35, because we need to use the one we've got beside, 35 over sine, and again, we don't have the correct information. I don't know what this one here is. That's 12, that's 162, so that must be 6. Here I'm dividing by sine 12, so to get x on its own, I take it over in times. So x is 35 sine 12 over sine 6. Type that into a calculator. It comes out 69.6, what units again? Metres. Okay, that means if I go back up to my original picture, this line here is 69.6. That gives me a length in my small triangle. So that's 18 degrees, that's a right angle, and that is 69.6 metres. So now I can find the height of the cliff. Now I can find the length of that line there. Again, you can, if you remember how to do it, use SOHCAHTOA for this. Most people forget SOHCAHTOA, so we are just going to use the sine rule again. Okay, so A over sine A is equal to B over sine B. Yeah, let's put some information into this. The one we're trying to find, across from 18, so x over sine 18 degrees is equal to 69.6 over sine 90 degrees. Here I'm dividing by sine 18, so I'm going to take that to the other side and times. And if you're using SOHCAHTOA, this is the line here that you'd get to, but you just wouldn't have the sine 90. Type that into your calculator then. Ooh. Come on. No. Okay, do it this way, divided by sine 90. Don't really need to divide by sine 90. Sine 90 is just 1. So 21.6 meters. Okay, I'll leave you to try some of these then.